Hello and welcome to another video. Today we have a ginormous Z590 Steel Legend board here. So let's have a look at it. So let's see, we have a letter again. The board, it's a Z490-F. Okay, it's not what was written on the packaging. Okay, this board belonged to my girlfriend. From one to another time it just turned off and wouldn't turn on him anymore. And here we can see a burnt component right there next to the ATX connector. So let's have a look at what that will be. So we probably have a short circuit in some kind of form. So we won't be turning this board on, obviously. And we will have to take a look instantly under the microscope at that area. So let's get that in. Oh, the board it smells burnt already. Wow. Just from taking it out, you can smell burning. Okay. So, next to our ATX connector. Right here in this area. So, this is some sort of transistor that is burned up here. It has gotten really hot. Like, this thing has gotten hot to the point where it just turned into ash. 22K I can see. Let's get some... Let's see if this just... Oh yeah, it just disintegrates. Oh yeah, just pieces of it falling off, as you can see. Okay. Big question is, can we remove this without damaging anything? Let's add some leaded solder to all of the parts here. So it would be really interesting what this is for. I think this is this has to do something with RAM probably. It's not the 1.2 volts RAM that is created here. But I wouldn't think that this is only like for VTT. Because RAM is being created upstream right here, where these MOSFETs are, and this big inductor is here. But I cannot tell you what this is for. It actually might be for VTT. Let's see, let's get some good amount of solder. Oh yeah, this thing just... Yeah. We don't even need hot air, it just broke. It just damaged to that point where I was just able to use the soldering iron to just remove pieces from it. Because it's just broken in half. But it doesn't look like any of our pads are destroyed, which is very good. So the burning just stayed within the component mostly. And now let's clean the area up. So let's see now. This area is now cleaned up. And there's some charring here under there. But it is fine. It's just the masking that got taken off right there. We still have the pad that goes to here. This might be something connected to the 5VSB, I think. Because this big trace coming from here is, I think, 5VSB going into there. Let's get the multimeter. And let's just see, without going into a board view, just see if we can get some connections. And see what is connected to. So one probe is into the 5VSB now. Let's see. Yeah, that is 5VSB. Okay, and now the question is this 5 volts? No, this is not the 5 volts. So we have 5VSB right there. Don't know what this is going to be. This is not 5 volts, 12 volts, also not 3.3 volts. So let's see, is this connected? It's also not connected to the DDR voltage. Because it just goes into the board by through these vias here. And then we have, is this ground? Let's see. This is not ground right here. This is not 12 volts, not 5 volts, not 3.3 volts. Okay. So we will have to take a board view. So we know this is 5 VSP right here. We do not know what these are though. And we do not know what that controller is for. So let's see if I can find a board view for Z490-F, I think this is. And let's then see what the area is supposed to do. So I have a similar board view. This is a Z490E gaming and not an F. But this area looks very similar. So let's see. We have a regulator UP8815. And yeah, this is, like I thought, this is responsible for VTT DDR. So this isn't a high power line, not a high voltage line with 0.65 volts. This is a power MOSFET, EMFAOPO2J, okay. No idea, haven't heard that before. What we have here, we have 5 volts auxiliary power switch P gate. We have 5 VSB, which we knew, and then we have 5 volt dual. So this is a MOSFET that is being switched via 5 volts dual. Yeah, this is the gate, pin 1 is the gate, and this triggers 5 VSB into 5 volt dual. And this switch gate, who controls that? This is controlled via this 0 ohm, and then going into the bottom right from this controller. Oh, this controller here takes some power good signals, PCU power okay, then some sleep states and similar things, and then switches this output right here that then goes to that 0 ohm resistor and to another resistor and another oh no, this one isn't assembled, so this one doesn't matter pretty surely. But there are more power good gates. Yeah, there's some more switching on here with 3 VSB, 3 volt dual and similar stuff. So this is control circuitry for when the 5 volts ATX turns into the 5 volts VSB, and we get that to this MOSFET right here. So how can this burn up? I'm not too sure, to be honest. Like, why would this burn up? Like, there's no connection to ground here. Only if either the 5 VSB or the 5 volt dual get shorted to ground. This switch gate very likely isn't going to get shorted, and also there isn't much power behind it. But behind the 5 VSB and the 5 volt dual there can be a lot of power. But that would mean that one of these might be shorted to ground. So we will have to check if this or this is shorted to ground. So let's check that then. And I will also have to see if I can get a MOSFET like this one. So back on the board, let's now get a connection to ground. And let's see now for the resistance. So this was the 5 VSB. The 5 VSB has high resistance, that is good. This is 5 volt dual. And 5 volt dual is short circuited. Okay, this makes sense then. So we have a short circuit and 5 volt dual. This is why this transistor blew up. So the transistor is just a victim of 5 volt dual being shorted. So we will have to see why the 5 volt dual is shorted. We will have to inject voltage, but there's a lot of heat sinks on here on this board. So I will have to take off some of these heat sinks. Let's switch into the overhead view again. So as you can see, there's a lot of heat sinking everywhere here. And I will have to take that off in order to be able to actually monitor this board properly under a thermal camera and to actually see all of the things that could be getting hot. So let's hope it's just a dead capacitor. The resistance is very low, so it's really like 0 ohms on the resistance, which could lead to really a burned up capacitor, because if you have like a dead MOSFET, you often don't have straight 0. So yeah, I'm hoping for an easy one right here with a dead capacitor. So let's have a look. So I have removed most of the heatsinks, but I will keep the heatsink for the PCH on here for now, and the heatsinking for the VRM. This one is also connected to the VRM right here. I will want to see if I can already spot what is wrong. If not, I will have to continue to take off these heatsinks. So let's get the thermal camera and also the power supply in here. We're going to start out with just a single volt in order not to blow anything up. And we will have to see how much current we already be taking at that point. So I will have the thermal camera here for now, because I need to get an overview of where the short might be. So let's have a good look and let's see how much amps this takes. 2 amps. Something should be getting hot, and I see something. Oh no, this is just where my tweezers are. I will need to find a different place to inject voltage just to be sure that that isn't, so that there's no capacitor that is shorted there. Let me quickly find another point. So I think I found it. Look there, it's under this heatsink right there. If I inject voltage, you see that? Heating up right there. Okay, I will have to take the big heatsink off, and then we can have another look at that. So let me quickly get all of this off of here. So now it's taken apart. The area that I suspected is somewhere around here, and I see a capacitor that looks kind of bad. Let's go under the microscope. So if we are lucky, it's this capacitor right there. Because I think that was right under the heatsink, and I think that has gotten hot. But let's go into the overview, inject voltage and see again. Right there I can see something heating up. This might be a controller actually. Let's zoom down on that a little bit and also get the macro lens onto here so we can see better what it is we are looking at. Oh, this might be a capacitor all along. It's between those, and there's just a single capacitor right there, and it's getting at 1 volt 5 amps, and it's like 40 degrees. If I would now pump this up to 5 volts, this would explode, this capacitor. And now you can see it very clearly when I tap it, that capacitor is dead. So let's go under the microscope and remove that one, and then see if our board is already in a working state or not. So the shorted capacitor in question should be this one right here. And you cannot see that this one is shorted. This thing looks immaculate. Maybe if we're looking for the side, we could see a crack or something like that. But I'm not really interested, to be honest. We clearly saw that it was shorted, like with just a single volt getting this hot. And we're going to take the quick path of injecting voltage, of trying to take it off with just the soldering iron, heating it up from both sides. Come on. Okay, the tip isn't big enough for this. Nope, not getting it off. Okay, hot air it is then. That capacitor beat me. So, taking off the too much solder right here. It has leaded solder on both sides. Let's just hot air it off. Capacitor is now out. Now let's clean it off. Now the area is clean. Let's now go back to our original area where we was. And let's check for the resistance now. So let's see now. And now we have high resistance on 5V dual. That is great to see. So that was a shorted capacitor. Now I have to go into my donor boards and see if I can find a MOSFET like that. If I have anything similar to that. I do not know if I do have one of those. And yeah, and then we can solder that in, and then we can try to actually power this board on, monitoring the passive standby voltage. And yeah, just continue from there on. So let me first have a look if I can find a MOSFET in question. So I do not have the right MOSFET in here because this is a very special one. This SOT23 is a P-channel MOSFET with like 3.4 amps, which is a lot of amps for this small package. This is really a power transistor that was here. So what we are going to do, we're going to be jankily putting in this one. So we have our gate, we have drain and source. We have on pin 1 our gate, pin 2 is our drain, and pin 3 is our source. So we will first, what I want to do is put in that tab onto here. And what we are going to do, we are going to drill out a little bit of this solder mask in order for us to be able to put this on in a different way. Because we need more space than is on the board right here. But we're just going to be taking this space for ourselves here. So we're going to be drilling away this solder mask right here. So after drilling it out a little bit, let's clean off. Now we have a little bit more of an exposed pad. So what we're going to do, let's add some solder onto them in order to give us a bigger area to attach to. Like that. This is going to be our tab. So let's see. We're going to be probably making a little bit like a floating MOSFET onto there. Okay, my janky solution I think is finished. Let me show you. So what we have a connection from the gate right there to that pin 1, which is the gate of the transistor, just via this wire here. This is enameled wire. Then we have the drain connected to that side right there, which is the middle pin. This is our output basically. And then we have our source to the 5 VSB connected right there to that side of the capacitor. So let's check with the multimeter that I didn't bridge anything that I didn't want to bridge. So let's go into continuity mode. So we are in continuity mode. And let's see now. This is the output, the 5V dual output, and it's not shorted to ground. And I go now to the pad where that capacitor was, and we have a connection. So that is fine. We now connect to this pin right here. And this pin right here is connected to that side. There's the switch, so it's not shorted to there. And it's also not shorted to the 5V dual. Or is it? Did I actually accidentally connect this to the 5V dual? Is there a solder bridge right there? Because this seems to be connected to there. Yeah, I might have a solder bridge. Could that be checked that? Let's make sure that this isn't touching anywhere. Let's try that again. Yeah, now it's not, I think now we got it. Now it's not shorted anymore. So there seem to be, yeah, no, now it's good. Now we have no connection anymore. So this gate is now connected to that point right there. We have then the connection of 5-volt dual, which is not connected to the 5 VSB directly or to here. And the 5 VSB is also not connected to there or there. And this then needs to connect to the 4th pin of the ATX. Yup. So this is janky, I know, but I want to test this out. I will be ordering the right component for here, no question. But I want to see this work first, to see if this board can be, if anything else is damaged or if the board will work like that. And if we just need the proper transistor in there. So, because there's a lot of problems with the design that I have right now, because there's no heat sinking for this anymore. Normally it should be connected to the board via big solder pads, which also grant them heat sinking, and that is not given here anymore. But I made sure that it won't instantly burn up. The only wire that I've used is for the gate, where there's no current flowing. But for drain and source, I made sure to have a proper solder connection to be able to pass some current. So like this, we're now going to be trying to build this board up and then see. So we're going to be putting a processor and RAM into here. The socket looks almost perfect. I can see something in the bottom left. Let me quickly look at that. Yeah, there's a pin that is slightly bent. Let's bend that back. We will have to do that first before powering this board up. Have a look. That bottom left pin is just a little bit bent right here. Right, this one. Let's do it like that. Yeah, that is better. The rest of the socket looks good, but that had to be done because that was quite far out. So let's now put a CPU into here then. So we have a Celeron G5925 here. And now the big moment. Let's see for the passive power consumption if this is going to blow up or not. 150 milliamps. That looks very good. Okay, let me get a display hooked up to here. So let's get the post screen also into here. Yeah, we have boot LEDs right there. I'm not going to be connecting anything else for now, I think. Well, this is an Asus board. We might be able to use the debug that they have. No, it's different on this one. So we're not going to be bothering with postcodes. Let's just see how this board will behave. So pressing the power button, go. 2 amps, that looks very good. Turned off. Now turn on please by yourself. That is very good. DRAM LED, 2.5 amps. DRAM LED off. Do we get a VGA LED? VGA LED, 2.2 amps. Do we get a picture? It's cycled again. DRAM LED. VGA. And there's the boot screen. Very, very nice. So our Janky setup worked. We are on the boot LED and we have the boot screen. That is very good to see. So I'm pretty sure that this board is already working. I will be quickly going into Windows. But so let's quickly get into Windows just once, just to see it. But the board wasn't turning on at all before because obviously the 5 volts VSB was shorted with the 5 volts dual together. And there was no way of this board actually turning on and working. So yeah, now pretty sure everything is working alright again. We get some beeps, but those shouldn't matter because the board is working. Let's get a USB keyboard onto here. And let's then get into Windows. this is the great thing about Celerons. They have so low power consumption that most power supplies can handle that. Like, it doesn't even spike up to 5 amps. Most of the time it's about 2.7, 2.3 amps. So yeah. So let's see. There's no BIOS battery. That's why it's complaining all the time. Let's see if we now get into Windows. If it now wants to take the boot manager by itself, or if I have to pick that one out. Yeah, I will have to do it myself. So let's go into the boot manager, because it's complaining about a CPU fan error, because I have just a 2-pin fan in there and not a 4-pin one, and it can't monitor that. But as you can see, we are preparing devices for Windows, which is very good. And there we are, going into Windows. Very great to see. So I would call this board also fixed. I will order the right part, just solder it on there. There's nothing really more to that. Just desoldering what the mess I've made and just putting in the small transistor. But we've proved that this board works, even with the bot job that we did, because sometimes you don't have the right parts on hand and you have to get creative, and that's one way to do that. So, thank you very much for watching. I hope you enjoyed the video. I hope you learned something. All of my tools are always linked in the video description. Thank you very much, and goodbye.